Okay. All right, sorry. From. I know. All right, there we are. Okay, so should I just carry on from where I was?
Yeah, I think we can skip the stack. We can skip the Stacklikeness section
Okay.
and move right after the Stacklikeness.
Also, I skip this part.
Yes, we
All
can skip
right.
that.
Okay, so we're going to be skipping this part. Sigu seems to be in a spirit to explain it, so he'll do it for us.
No, I'm not going to explain the Stacklikeness. I'll use another example.
Oh, okay, fine. Awesome. So here, mixing in a module into a class. I can start from there, right?
Yes.
All right. So we have this stack-like.new. This is literally a module that we created up here, so we won't use it. What have I just done? Not working. I have no idea what I did. Yes.
I also have no idea what
Sorry.
Oh,
Full screen. Oh, that. Okay. All right. So.
So I think we can do that. Now that Emma is back, we can do that.
We do the stack like.
No, no, it's not actually the Stacklikeness. I want to explain something about modules that will the same as Stacklikeness. Alright, so right, okay, I can use yours. Thank you. Thank you. So I'll be using my computer talking through her microphone. All right, I need to share my screen. Okay, let me. I don't need this. Share screen. Okay. You need to lock on my screen. Thank you. Okay. So if you check on Ruby docs, is it that? Let's see. Okay. Let's go to the 2.5 core and we look at a module. There's a predefined module called enumerable. Okay. So this enumerable module, what it actually allows you to do, an enumerable mixin and a module are the same thing. So it provides a collection of classes with several traversal and searching methods and the ability to sort things out. The class must provide a method each. Okay. Whatever you have, it must provide a method each, which yields successive members of the collection. Okay. So you can have max, min, sort is used. You can also implement using the hash spaceship operator. Okay. So we can have a module called enumerable as long as you define a method called each in it. And you can also compare. Okay, so let's see. So arrays normally include enumerables. This module enumerable. So if you go to your terminal, let's see, how clear is this? Bigger? Okay. So I can start on pry or IRB if pry is acting up. So we can create an array with that, then call dot each on that. Now if you call dot each and pass it a block, then you put a, it will print every element in the array. Now the array gets the dot each method. It has that ability because it's an enumerable. You can enumerate through it. Okay, so we can also create our own enumerable and mix in the enumerable module. Okay, so just random search on the internet, create enumerable class in Ruby. Random search. Okay, how do I use enumerable mixin in my class? Stack Overflow, our good friend. Let's see what they offer for us. Okay, it's easy. Just include a numerable and define an each method, which is often okay. So you need to define each. Okay, so we can create a class called a team, include the enumerable method, then define an each method. Okay, we can do this. Let's copy this class. Trials, then call initialize and say that at members will be that. Okay, then we need to define each method, which takes in a block. Yeah, I think that's done. But this method, trials.new, it works because it expects any number of arguments for the members. Okay, so let's say Getty is going for trials dot new Getty. Okay, so Getty, nothing is being printed because we're actually not printing anything here, right? So according to this example, we can see you can call just a minute. Okay, so let's say we have Getty, we have Eba, we have Moses. So this is the team that is going for trial. Okay, oh, it should not be Getty. You can call it Mobus. Mobus. So when you say Mobus, then we want to see, from this example, you want to see, you call map. Which other example does it? Count. Let's try and call count on it. See what happens. Mobus.count. Nothing happens. Okay, but we want it to be able to tell us how many people are here. It should be able to tell us 3. Okay, adjust your mics. Let me try again. Moses, is it clear now? He's requesting that you adjust our microphone. Let's see. Just a minute. Is it okay? Okay, if it's okay, fine. So we want it to give us back the count to be 3. Now this method does not in any way define count method, but we want to include that. Yeah, we want to include that from the enumerable module. Any questions so far, by the way, guys? Get is okay. Moses, are you okay? Okay, you can type it in. Eba, you okay? Okay, no worries. Now, let's head over to define the class trials again. And okay, let's define the class trials again. Define that. Oops. Yeah, this is okay. This actually means that you, in IRB, this means that you're in line 2, 0 indents. This is line 3, 1 indent in. Line 4, 2 indents in. Yeah. So let me copy this again. And this time, include the enumerable. Then define the each method. Okay. So class, we, end. Okay. So it has each and initialize. Now, when we say the team equals we dot new, then we pass in our names again. Let me try this today. No, which one is the double? Is it like that? Ever? Is that the correct spelling? Amezupa. Okay. Yeah. I always get it wrong. Okay. So those are the we. Okay. Now we want to say that we want to ask how many are there in the team. Dot count. It now tells us 3. And we did not define any method called count. It's because we included the enumerable module. Okay. What about sort? Will this work? Let's see. Yes, it does. It sorts in alphabetical order. Okay. Any other method from the enumerable? Collect, cycle, drop. Cycle goes through like it goes through it over and over and over forever. If you cycle 2 times, it will go through it 2 times. Can you try that? So let's say the team dot cycle. We pass it a block or what? Yeah. Cycle 2 times. Pass it a block. Then we print the member. Close the block. So it prints them twice. Moses and so on. Getty, Moses. Now, if you do this 10 times, it goes over it 10 times. Yeah? We can let it go infinity times by not telling it the number of times. Okay. Any questions? Guys? None? Okay. So modules enable us to include functionality into our application. Like right now, we just defined, oh my God, I didn't have to do that. Okay, we've overwritten. Okay, I think we're still safe. So what we actually did was, okay. Scroll down, 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 down. I don't know. This is my whole history. Okay, this is not helping at all. So what we did is to define, we defined a method, a class called we, included the enumerable. So we are able to sort, we are able to cycle, any method that is there in the enumerable, we are able to do that. So that's why we normally have modules in Ruby. Yeah. No, I'm not going on. Okay, Get, you can continue.
You're doing so good explaining everything. You could have just carried on. All right, so let me share my screen. Thank you for that, Sigu. That was helpful.
Thank you. Log onto your screen.
Oh, yeah, I should. Chrome. I'm logged to mine. Awesome. Okay, so mixing a module into a class. That's basically what CQ was talking about the whole time. So there are like 3 ways for mixing in a module into a class. First, there's the require method. Then there's the include method, and then there's the prepend.
No, I think right here, mixing in Stacklike. So Stacklike is another module that was created way up.
Yeah.
So at this point, we are only using the include. So we can just talk about this include.
Okay, so we talk about the include.
Yeah, I think why you mixed up. Yeah, let's talk about these 4, 1, 2. Let's just
Okay. All right. All right, so as you've seen, modules don't have instances, so you can't do this. We can't call a new instance of module, as we've seen, but we can do this for classes. So to create instances, you need a class, and to make those objects stack-like, you need to call this stack-like method that we still haven't talked about, but we will. You'll need to mix in the stack-like module into a class. But, sorry, Sigu, what you're saying?
Stack-like is another module that was created in this particular book. So you can equate that to enumerable. So to create an instance objects, you need a class to make those objects stack-like. So in our case, to make them enumerable, something that you can enumerate. Okay. I guess you can relate the two.
All right, thank you, Sigu. So the business end of the stack class in this listing is the include statement, which has the effect of mixing the stack-like module. It ensures that instances of stack exhibit the behaviors defined in stack-like. So, Sigu, I'm seeing they're discussing the stack-like module a lot. I think we should pass through it first. What do you think?
Okay, I don't think there's a problem going through that. Just scroll up a bit.
Right. Okay, it is.
Okay, so at this point, we are defining a module, our own module called Stacklight. Okay, let's go there. We define that. There it is. It's a module called Stacklight. It has a method called stack. You can add to stack or you can take away from stack. Those are the three methods that it has. Okay, scroll up. So basically, what it does is that it enables you to add one thing at a time, but when you want to remove, you remove the last one first. Just like dishes, when you have dishes, the plate that was put in first will be
The last to be
the last to be used. If I'm assuming a normal family where people don't rush for the plate in the middle or the lower. So if you guys have the plates stacked on top of each other, then if you want to use the plates, then you usually start with the top one. Okay, so you start with the one that was put in last. Another example of that is if you're getting into a car which has one door that you can use to get in and out, it means that the first person who got in cannot be the last to get out. The last one who got in must be the first one to get out. Is that making sense? To both Eba and Moses, and not both Eba, Moses and Kate. I can see she's nodding her head. Is that making sense? Moses, Eba?
I'm listening, but yeah, it's first in, last, first, no wait, last in, first out.
Yes.
Yeah, it's, yeah. We explained it like the place in the cafeteria, right?
Yeah, the place and the queue.
Yeah.
All right, awesome. Thank you. Okay, so that's technically what this stack-like module is doing. So we have a stack, and to add to the stack, you simply push. When you push in Ruby, you add an object in front of the enumerable or the array. And when you pop, you remove the last object. So this is typically mimicking the last in, first out principle of stacks. So when we move here, this is exactly what this guy is talking about. So when he talks about the stack-like module, he's talking about that module that operates in the last in, first out principle. Okay, so where were we? Here. So the most obviously stack-like thing is probably a stack. Save the code in the following listing, blah, blah, blah. So here we require the stack-like object. So this is, oh, sorry. So I'm being corrected. We require files, but we include modules. So here we're simply requiring the stack-like file, right? Am I okay? I hope so. So we have a class stack, and then we also include the stack-like module. So if at all we want to use that file that has the stack-like module, we have to require it first so that we can include it in the class that we have. So the business end, yes, you go.
Moses is asking a question. Is it stack like .rb? Yes. When you require files, you don't actually need to put the .rb at the end. So we have a file called stacklike.rb. It has the module called stacklike in it. Okay. So when you do require relative, it requires the file, then include stacklike. Now it includes the module that is in the file. The file doesn't have to have the same name as the module. You could have called the file Moses, so you could have require relative Moses. Then if Moses has a module called stacklike, then now you include stacklike.
All right.
Does that make sense?
Awesome. Thank you, Sigo. So the business end of stack class is this listing. In this listing is the include statement, which has the effect of mixing in the stack-like module. It ensures that the instances of stack exhibit the behaviors defined in stack-like. So we have this class stack. We can always create instances of this class. And anytime we create an instance of the stack, it can have the module that is inside the stack-like module. Yeah. So yeah, that's it. So there's a brief message here that talks about the difference between require and include. So you may have noticed that when you use require or load, you put the name of the item you're requiring or loading in quotation marks. But with include and prepend that we'll talk about later, you don't. That's because require and load take strings as arguments. So require and load, we've seen that this requires the file that we're about to use. So it takes strings. That's why we have to place this in double quotes. Yeah. And then include takes the name of a module in the form of a constant. So this is the name of our module, stack-like, and it's a constant since it begins with a capital letter. So more fundamentally, it's because require and load are locating and loading disk files, whereas include and prepend perform a program space in-memory operation that has nothing to do with files. That's simply what we've talked about. So when we require, we're intending to take a file from somewhere, so we're loading the files. And when we're including, we're just taking the module that's already existing. Yeah, so the two operations tasks often go together, but they are completely different from each other. Awesome. So notice that our class's name is a noun, whereas our module's name is an adjective. So our class name is called stack, and our module's name is called stack-like. Like if our class name was enumerate, our module name will be enumerable. Yeah, that makes sense. Any other example from you guys of nouns and adjectives? Eba?
I'm trying to understand the whole thing as usual.
Okay, no worries. So now
I'm
classes
so
are
sorry,
nouns.
guys.
It's okay.
Now classes are nouns and modules are adjectives. So if you have a class called walk, how would you call a module? Walkable, if I'm not wrong.
So wait, classes are nouns
Yes.
and modules are
Adjective. So if you have a class called person, how do you call the module of? Okay, because modules actually, what it actually does is it defines something that behaves like. That's the adjective thing. It's a description. So if you have a class person, then you need a module for the person. It means that you want something that behaves like a person. Okay. Now, something that behaves like a person is how can you call something that behaves like a person? Human. How do you call something that behaves like a person? You can call it person-like. Okay.
yeah.
Yeah, you can call it person-like. You can call it Is human an adjective? I think human is an adjective.
It's a noun.
No.
It's a noun.
Yes.
Are you human?
No, yeah, it's a noun.
No, that's an adjective.
No. Humane is an adjective. Or?
Human is a adjective. Yes, that is
Human
true.
is an adjective. Yeah, exactly. So you can have a module called human, which actually means that anyone who includes the module, we assuming they're behaving like humans. Okay? You can have a module called enumerable, which means that anyone who includes that is behaving like they can be enumerated. You can count them, you can map them, you can sort them. Okay? And enumerable is something that can be, I don't know if enumerate is making sense. Okay, to enumerate is, it has to be a collection. Okay? Audio is fading away. Let me use your microphone. And enumerate. Wait, just wait. Enumerate actually means something. Okay, in your house you can enumerate. You can enumerate the utensils. Okay, you can enumerate. Okay, let's say you can enumerate spoons. You can enumerate plates because you can count how many plates you have. Okay, you can sort plates by the colors. You can say yellow plates to the left, the red ones to the right. So it's a collection. That's something that you can enumerate. So it's an enumerable. Okay. Something that you can't enumerate is you can't enumerate one plate. Okay. You can't count one plate. You can't sort one plate. I don't know if I'm making sense. So if it is behaving as if you can sort it, say that all the yellows together, all the greens together, all the tall people should be like this, that is something that you can enumerate. So it will be enumerable. If you can count, then it is an enumerable. If you can find the maximum or the minimum or the average, then it is an enumerable. Okay? For example, we are in this mob. It's me, Eba, Getty, and Moses. Those are 4 people. So we can actually count them. Another thing that we can do to these 4 people is to say who is the tallest. So we can sort them in the order of first of all, we can sort them in the order of their tallness. We can sort them in the order of their age. We can say who is the oldest. So it only returns one person from us. Who is the youngest? It gives us one person from us. So all these are enumerable. It behaves as if you can do any of those operations to them. Okay? I know this is confusing, and I'll repeat with a different example. So if you go to school, in the class, it is a collection of people called students. Okay? So I'll share my screen again. Module enumerable. Okay, you can lock on my screen. Get it? Okay, so I'll use the enumerable again as a module. Okay, now let's check on the all method on the enumerable. Passes each element in the collection to the given block. It returns true if the block never returns false or nil. So we can use this for our class example. So you go to a school, 3rd grade, take all the students in one by one, okay, and ask them if they are below 15 years old. Okay, now this all method is checking for every student if they are below 15 years old. If all of them are below 15 years old, then it will return true and say that all students in this school in this class are below 15 years old. Is that making sense? I need affirmation for that before I continue.
Yeah.
Okay. You're not muted. Oh, you should not be muted. All right. Let's go over to the next one. Any. This is an enumerable. It passes each element of the collection to a given block. it returns true if the block ever returns a value. It's like a teacher walking in and asking, did any of you do the assignment? Okay. Did any of you do the assignment? If one person did it, then it's a true. If no one did it, then it's a false. Okay. If the teacher walked in and asked, are all of you above 15? Then it means it is only valid if everyone is above 15. Okay. All. Okay. The next one is chunk. We can skip that. It's a bit not English like. Count. In a class, you can go and count, ask how many are here. Okay. That's count. Cycle calls each element repeatedly n times. Okay. So an example of the class again. Let's say we have a party, a class party. Okay. Each class member will be taking a bottle of beer. Okay. And every time you go for a bottle of beer, you only take one. Now, if you're told that you can only take 3, it means that the whole class will go around 3 times. And every time you go around, you pick 1. So at the end of it, everyone will have had 3 beers. That's cycle. Okay. So anything that can be done in a collection of people is an enumerable, if that makes sense. Let's move over to drop each. Entries, find all, find index. So all these, you know what first does? It can come to your class and ask who was first in your previous test. Okay. Who seated first? Okay. It can sort the class out and say, I want you guys to be arranged in an order depending on your height. The tallest to be in front. So that's sorting. Okay. So you go to a class and tell them, I want a straight line from the shortest person to the tallest. So that's sorting, enumerable. I want the first person in this line. So the tallest will come out. Okay. Anything not making sense again? Moses, everything okay? Okay. All right. Thank you for understanding that. So a module explains how something can happen. If it's something you can enumerate, that's enumerable. The class normally uses the noun. So any other example? Anyone with a vehicle? A vehicle, that's a class because it's a noun. Okay. So which kind of not enumerables, which kind of modules can vehicles have? Movable? Paintable? Okay. Any other? A module for the vehicle? Animal? An animal class? Any other module? Not crawlable. Crawlable is not allowed. Edible? Oh, you can have an edible. A class can have an edible module. Okay, which means they can eat, or it means they can be eaten. They can be eaten. Really, that can be a method. Yeah. No, it can be a module. Yeah, but okay. Hey, okay, Dennis has joined us. Hey, Dennis. Okay, he's now concentrating. He was here and left. Okay, so any question? Anything to be cleared up, because we have some 10 minutes, so we can continue or clear up everything that we've done so far. Questions? Anything that's not clear about the modules so far? Moses, everything okay? Can I see the book? Let's see the book. Okay. Load versus require, include. Okay, just to clarify on the require and include thing. So you require, the method require, we can search that. the method require? Core, I think it's a core method. Yeah, I hope so. Is my screen shared? Require, here it is. It takes in a name, loads the given name, returning true if successful or false. Okay. So the name, if the file name has an extension .rb, it is loaded as a source file. If the extension is all these or the default shared library, blah 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 blah. So these are strings. It checks in a string. Require relative also takes in a string. Tries to load from where the file is. Okay. Now include takes in let's see, include a module, invokes module. So it takes in a module, and modules are all constants. So module names must start with A, with uppercase, not A. Must start with an uppercase. Class names also start with uppercase. Okay. Any questions, guys? Clarifications? It's on the A. Okay. Clarifications, questions? None. Okay. Should we call this off? No, we still have 9 minutes. We can't stop here. Let's look at the book. I think I can continue. Am I sharing my screen? Yes. Okay. Book. Where's the book? Dropbox. Books. Ruby. Well grounded. We should be not chapter 5. We should be in chapter 4. Where's the sad pin? Okay, Stacklikeness, we've gone through that. Okay, using the... Now have we done that? Okay, I think we can go to 4.2 because in my opinion, this is too much information that we actually don't need. And I've gone through this using the enumerable class. Okay, so you can read through this just to know what's happening. Okay, but I've explained most of it using the enumerable class. So modules, classes, and method lookup. Okay, so you have a class that defines a method, and you include a module. You mix in a module that has the same class name. So what really happens? That's something that will be answered here. If you are looking for a method, in which order do you do that? If right now you're looking for a pen EBA, where will you look for the pen first?
Is this a question for like, I'm in a call. Sorry, there are other people in the room. Do you mean like in the method or in the module, or do you mean like
No.
in reality?
No, generally, if you're looking for a pen right now and you need to write something down, where will you look for the pen?
In my bag.
In your bag. That's the first place you look for it. Okay.
Yes.
If you don't find it in your bag, what do you do next?
I look on my desk.
On your desk. So there's the order in which you look for things when you need them. Okay. So if you look for it in your bag and you find it, you'll use it. So even if there's another one in the desk, you won't use that. If you look in your bag and you don't find it, you go to your desk and look for it.
Yes.
If you don't find it, then you look for it somewhere else. Like you can ask this person seated next to you. So that's what you call method lookup. In which order does Ruby really look for methods? Okay. All right. So that's what we can discuss here. So you know that object receives messages. Okay. And the intended and the usual result is the execution of that method with the same name that we talked about. Okay. So it will always, the inheritance is usually in a way that ultimately you will inherit from the basic object. Okay. If you remember the inheritance tree, all inheritances go back to the basic object. So whenever you're looking for a method, it will be searched all the way to the basic object. Okay. It pays to answer these questions precisely, accounts for what happens. Sometimes they are even adequate if you say this object has a push method. Okay, that's not making sense. Okay, let's illustrate examples of a method lookup. Okay, in the interest of working towards a clear understanding of how objects find the methods, we can go back to references and write some methods and modules like C and M. Here they are. Okay, it will help us understand all that. Now, the instance of the method report, where is that? Okay, so we have a module M with a method report and a class C that includes this. It mixes in the module M. D inherits from C. Then we have an object of D. Okay. Now module M is mixed into C, repeating what I've just said. Okay. So we can say that through this cascade, the object gets access to the report. So if you look at this, D inherits from C, and C includes M, and M has the report. So you can say d.new.report, and it will call this by looking at it throughout, and it will find it in the module. So that's what we call lookup, method lookup. So how does it do the method lookup? Okay. Yeah, go on. Oh, it's only 3 minutes. So we can go through this for the next 3 minutes. You're the object and someone sends you a message, okay? You have to figure out how to respond to it, or even if you can ever respond to that. Here's a bit of an object of consciousness, okay? If someone tells you to report as an object, you have to try find the method for reporting, okay? How do you do that? So I'm an instance of class D. Do I have the method report on me? It will be no, because right now I don't have any method defined, so I don't have it. What is the next thing that you do? It's like looking for the pen. You looked in the bag, you didn't find it, for example. Do I have any modules? Okay. So you ask, do I even have a bag with me? Do I have any modules? If you don't have a bag, then you say no. So you won't look for it in the bag. The next thing is, where am I seated? So do I have a superclass? Check if you have a module, then check if you have a superclass. If you do have a superclass, then check, does it have the report method? If it doesn't, in this case it doesn't, I have a superclass called C, okay? Then C does not have a method called report because it only includes M. Up to that point, we okay? So does C mix in any modules? Yes, it's M. And does M have that method? Yes, it is. Okay, I'll execute that method. So ultimately we find it. I'll repeat. You are class D, okay? You have an instance and you're told to report. The first thing you do is to ask yourself, do I have it? The answer is definitely no, because there's no method called report over here. The next thing is to ask yourself, do I have any modules in me included? So do I have it? No. Next question, do I have any modules? Yes or no? If it's a no, then you ask, do I have any superclass? Yes, I do. What's the superclass? C. Okay? Then you move over to the superclass. So the order is check with yourself, check if you have it in a module, and check if your parent has it. Okay. Another example might be you need money. Okay. You check if you have the money. If you don't, check if you have any bag with you or a wallet. Check inside. Okay. If you don't have a wallet or a bag, then ask your parent. What will your parent do? They'll do the same thing. So let's say you go to your dad. your dad will check with himself if he has any money. If not, he checks if he has his wallet right there. If not, he might talk to, I'm assuming your mom is included in your dad as a module. So it checks if your mom is around and asks, do you have any money so that I can give it to Moses or I can give it to Eba? Not, I don't. No, I don't. Or yes, I do. So check with yourself. After that, check if you include any module. If the module has it, well, you'll include it, you'll execute it. If not, check with your parent. Now, the parent will go to themselves, ask themselves if they have it. If they don't have it, they ask themselves if they have any module. In this case, they have one. Then they ask the module if they have the method report. I've talked too much. Do you guys understand the order of the lookup? Okay, Getty is saying yes. Dennis? Okay, he's saying yes. Moses? Eba said yes. All right. Okay, Moses gets it. So that's how we do lookups. And there will be some change in how it's done later on in this chapter. So don't get shocked if that happens. So we need really to understand this so that later on when you get there, you can understand. Now, next time we are going to ask, how far does it go? After asking for the money, okay, bye, Eva. After asking for the money, how far do you search for it? Will your father go as much as going to the church to ask for the 10 bob that you want? So that's what we're going to discuss next time. That will be, when will that be? Thursday? Are we having that on Thursday, really? No, we're not working on Thursday. So our next mob will be on Monday next week. Okay. All right. Bye, guys, unless there's another thing. Okay. Anything else? All right. Bye, guys. Okay, Mosi, I'll do that. I'll send you the link for the M-Pesa. The M-Pesa video or which one? Please stop the recording.